Welcome back to Quantify Your Career, and let's answer the three questions I had asked a couple of days back on covariance matrix. So the first question was, if the first eigenvalue of your covariance matrix explains 90% of the total variance, what does it say about your data or asset universe? The correct answer was, it is driven by a dominant common factor. So in linear algebra, eigenvalues of the covariance matrix tell you how much variance is explained by each principal direction or axis in the data. If the first one explains almost everything, your dataset lies mostly along a single direction in space. Your dataset may appear multidimensional, but it really behaves like a single variable system in disguise. Think of it like a group of microphones picking up different sounds, but when you run the signal analysis, it turns out they're all mostly picking up the same voice. Now, question 2 was, what does it mean if your covariance matrix is singular? The correct answer is, there are redundant variables. A singular covariance matrix cannot be inverted. That usually happens when one or more variables are linear combinations of others. In practice, this means that the dataset contains repeated or dependent information. It's like getting the same answer phrased 3 different ways. You think you have more data points, but you are really hearing the same thing over and over again. So when your matrix is singular, your data does not span the full space. You've got maybe fake variety that can break algorithms like PCA, LDA, or regression. Question 3 was, if your covariance matrix is diagonal, what does that say about your features? The correct answer is, they are uncorrelated. In a diagonal covariance matrix, all the off-diagonal terms are 0. So that means the variation in each feature is entirely unrelated to the variation in others. Think of sensors collecting data in separate sealed rooms. One records temperature, another records temperature, another brightness, and none of them affect each other. That is statistical independence in action. So this is the cleanest possible structure, pure signals and no crosstalk. It is rare in real-world data, but it is often assumed in models for simplicity. Covariance matrix does not just summarize variation, it reveals the hidden geometry of your dataset. Learn to read it and you'll unlock the true structure of your system. Until next time.